That's okay. You won't be. There's no way your voice is going to be picked up on here. So if you don't want to be heard, that's okay. And also, I'm going to post this to Canvas. Everybody will have access to it. A lot of the times I'm not going to be talking, right? But I want students who aren't able to be in the classroom to at least catch the stuff that I am going to be talking about. So here we go. Let's get started with Canvas. Welcome to Math 111. Today is Friday, which is nice, May 3rd. We're going to start by looking at the calendar. I apologize for those of you. Maybe I can do share screen. Share screen. We're going to share that one. There we go. All right. So I believe if you're watching the video, you should be able to see this as well, which is good. Today is the 3rd. We're going to finish 5-1 today. You had a quiz yesterday. I hope that went okay. We're going to dive deeper into 5-2, 5-3, and 5-4 next week. And that's where we really get into polynomials and rational functions more than anything else. So if you're not solid on polynomials and rational functions, this is definitely the time to do some review over the weekend. You have homework 5 due tomorrow. You have a wrap up and a week 6 prep due on Monday, and then we come back on Tuesday. All right, we will have an exit ticket today, so I'll get that set up once you're all starting your work. Yeah, and now, are there any questions about the calendar? Okay, so I want to start by talking through chapter 5, in particular, the warm-up. I'm not going to go through the question as is, but I want to talk about these 3 different forms of a quadratic equation. So first of all, it does not say quadratic equation anywhere, but these are quadratic equations. And we give them names for their different forms. The standard form looks like any usual polynomial. The factored form, you can see the factors, and the vertex form shows you the vertex. So I'll go through where to identify all 3 of those. But first, I want to give you the names that I like to use. Instead of standard form, I like to call this y-intercept form. Does anybody have a reason why I might want to call this one the y-intercept form? Yeah. Exactly. You can just read the y-intercept right off of the function. You don't even have to do any work. How would you do it? You'd plug 0 in and find out what your answer is, but when you plug 0 in, those 2 terms disappear and you're left with the y-intercept. The plus and the minus is important, of course. I like to call this one x-intercept form. Somebody else, why I might call this x-intercept form? The second one? Yeah. Yeah, the x-intercepts you can just read right off. With a -7, that means x equals, or t, I guess in this case, equals 7. And the +1 means t equals -1. You don't have to do any more work. You can just look at it and it gives you the information you need. And I like to call the vertex form the max-min form. Anybody have an idea on why I like to do that? Yeah. Exactly. That's always going to be either your maximum or your minimum. It's going to be the point where it turns around. That's the value, and that's the input that gets you there. And how do you know if it's the max or the min? From the leading coefficient. So I will go through, I'll rewrite all of these and talk about all of that information. Now, actually, I think I'm going to do it with a graph. And I should be able to graph this really, really well because I have 5 pieces, maybe even 6 pieces of important information. Do we all know which way this quadratic function opens? Down, because the leading coefficient is negative. So here's my axes, and I'll make a little note for myself that it opens down. Do we all know where it touches the y-axis? Yeah. At 0, 14, right there. 0, 14. Do we all know where it touches the x-axis? At positive 7 and negative 1. So negative 1, 0 and positive 7, 0. And do we know where its turnaround point is? It's at 3 and it's at a height of 32. So here's 3 and there's 32. Is this the max or the min? Max, because it opens down. And so now I can trace like so. All right, so here's my standard form, standard/y-intercept form, which is minus 2t squared plus 12t plus 14. That's right there. Here's my factored /x-intercept form, minus 2t minus 7t plus 1. There's the plus 1. There's the minus 7. They switch, of course, remember, which, by the way, is pretty similar to the whole transformations of a function. Things are opposite when they're inside. And up here, we have my vertex/max min form, minus 2t minus 3, that's this line, plus 32, that's that point right there. Ooh. We're usually not going to ask you to switch between one form and the other on a quiz, but we might ask you to do it in the workbook or in a wrap-up. I want you to know how to do it, but what's more likely is we'll give you all three forms and we'll ask you about the function, right? If I give you all of these three, I could say, well, what's the maximum? Or I can say, when is this function equal to 0? Or I can say, what way does this function open? And you should be able to get all that information from one or more of the three pieces. All right, so one other thing I want to draw your attention to, if you flip to the next page, which is 114, they have this summary box up here. So I'll write it again. This is y-intercept form. This is x-intercept form. This is max min form. The y-intercept is the C, the x-intercepts are the R1, R2, and the coordinates of the vertex are HK. The H is a minus because it's inside, right? And we know things flip when they're inside. The other thing I want to draw your attention to is the A is the same for all of them. If you have a minus 2 in standard form, you better have a minus 2 in factored form and in vertex form. C, R1, R2, H, and K, those are going to be different for all of them, probably. But the A is always the same. All right. Last thing I want to do before I turn you loose for a while, I want you to go through this. I think you can do this. We talked about it. Is I want to talk about converting a quadratic from standard form to vertex form. So we're on page 116. There's a way to do it called completing the square, which you have to do for each and every function that you're addressed with, or you can learn a simple set of rules and use those rules for everything. Which would you rather do? You want to complete the square every time? Go for it. I love it. Anybody want to just learn the simple rule and use that? Okay, good. It's part of what math is, right? Learn a simple rule that works for lots of different things. Okay, so if you have standard form equals ax squared plus bx plus c, then there are two pieces of information. The three pieces. The leading coefficient in vertex form is still a. I just talked about that. H equals minus b over 2a. You read off your b, you read off your a. You make the b negative or the opposite of what it was, and you divide it by 2 times a. The x coordinate of the vertex. And 3, k, is your function with that value plugged in, i.e. f of minus b over 2a. Once you find h, just using those two values, you plug it into the function to get your output. If you know the input, you can find out the output. Right? That's just like if I said, what's f of 3? You plug it in, and it tells you what f of 3 is. Here I say, what's f of h? You just plug it in. So this is the y coordinate of the vertex. And then you just write your max min or your vertex form, a times x minus h. Don't forget it's minus, or flipping it. You have to square it or else it's not quadratic. And then you add the k. If you were to complete the square, you would end up with minus b over 2a, and you would end up with f of minus b over 2a. They both work. Do the one you like better. If you don't have a preference, do this one, because I think it's a little more straightforward. Now, because this is math class and I want you to learn math and not just formulas, I'm going to tell you why it is this, because I think it's pretty cool. Does anybody remember the quadratic formula? Right, quadratic formula. Can you still see that? No. Okay, I'll come back to this. Quadratic formula, which is, and sometimes you don't realize what it is, but it's telling you the x-intercepts are minus b plus or minus, but I'm not going to do plus or minus. I'm going to separate them out into two different ones. Minus b plus the square root of b squared minus 4ac all over 2a, and minus b minus b squared minus 4a, square root of b squared minus 4ac all over 2a. What do you know about the x-coordinate of the vertex in relation to the roots? It's in the middle. It has to be, right? Because that's where it turns around. That's the axis of the symmetry. But let's look. We had an example where we had a minus 1. So that's going to be minus b minus the square root of b squared minus 4ac all over 2a. And we had a root here, which was minus b plus b squared minus 4ac all over 2a. And how do you find the average of two numbers? Add them and divide. Minus b, and divide by 2, right? Minus b minus the square root of all that business over 2a. And then you add to it minus b plus the square root over 2a. What happens to the square root part? You had a minus and a plus, and so it goes away. And now you have a minus b and a minus b, and you divide it by 2. You get minus b over 2a. So that is the reason that works. All right, we've got a function that comes up, turns around like this, and that x-coordinate of the vertex is always going to be right between your roots. Which, by the way, Makes it really easy to go from factored form to vertex form. If I want to go to factored form and I have minus b x plus 1 x minus 7, then h should be the average of those two numbers, right? 7 plus -1, 7 minus 1 over 2. What's 7 minus 1 over 2? 3. And what was the coordinate? It's 3. So it's actually really easy to go from one to another, as long as you think about what does it mean to be in the middle, is to divide. All right. Anybody have questions about what's in this summary box? All right, well, I will invite you to continue working on 5.1. The learning assistants and I are here to assist as needed. For those of you watching the video, I'm going to pause the video unless I decide to continue talking in front of the group.